Plants are some of humanity's oldest allies, and they may become our greatest companions on Mars. They provide oxygen, nutrition, and a sense of life in even the most sterile environments. But can they thrive on the red planet? So far, the results are promising. On Earth, scientists have grown crops in Martian soil simulants, engineered materials that mimic the composition of Mars' regolith. Experiments show that many common vegetables like lettuce, radishes, and peas can survive and even flourish with the right nutrients and light conditions. Additionally, we've successfully grown plants on the International Space Station. In microgravity, astronauts have harvested zinnias and mustard greens. The key challenge on Mars will be whether crops can adapt not only to reduced gravity, but also to the Martian environment itself. One of the most critical concerns is safety. Mars' regolith contains perchlorates, chemicals that are toxic to humans. Any soil used for farming must be carefully treated, washed, or biochemically neutralized. Alternatively, crops could be grown entirely hydroponically, using nutrient-rich water systems without any soil at all. The true test, however, will come only when we plant seeds in actual Martian conditions. Temperature swings, radiation levels, low pressure, and limited sunlight all present unique obstacles. But plants are resilient, and with genetic engineering, we may be able to develop strains specifically tailored for Martian growth. There's also the issue of taste and nutrition. Will Martian-grown food taste like home? Will it provide the same caloric and nutrient value? Scientists are working on this as well, using controlled environments to tweak variables and improve both yield and quality. NASA has projected that the first human mission to Mars may occur as early as the 2030s. That might sound far off, but in the scale of space exploration, it's right around the corner. Before long, astronauts will begin growing crops not in labs or simulated environments, but on Mars itself. These early gardens will be symbolic, proof that life can be sustained. But as the colony grows, so too will the importance of Martian agriculture. A fully self-sufficient colony can't rely on food shipments from Earth. It needs fresh, local, sustainable growth. Enter closed-loop life support systems. These systems recycle waste products, water, carbon dioxide, and organic matter into usable resources. Plants help drive this loop, absorbing CO2 and releasing oxygen. When harvested, they return biomass to the system, which is then composted or reused. The result is a miniature ecosystem. And as we refine these systems on Mars, the technology may even help solve problems on Earth, particularly in remote regions or urban areas with limited arable land. But farming isn't just about calories, it's about connection. For colonists isolated millions of kilometers from Earth, tending to plants offers psychological relief. It provides a routine, a sense of care, and visible proof that life is still growing. Studies from the ISS show that astronauts find comfort in nurturing green life. On Mars, this comfort will be even more essential. Martian farms won't resemble sprawling fields. Instead, they'll be compact, vertical, and highly optimized. LED lighting will simulate day and night, while temperature and humidity are carefully managed. Robotic arms may assist in planting and harvesting, reducing the workload on human colonists. And over time, these farms could evolve into food forests, stacked ecosystems that provide fruits, vegetables, herbs, and even medicinal plants. Martian cuisine will develop its own identity, combining local resources with Earth-imported flavors. Infinity. Beyond envisions a future where Martian agriculture becomes a symbol of human adaptation, not merely surviving, but thriving. The first salad grown on Mars will be more than food. It will be a triumph. And as our colonies expand, agriculture may take on new forms. Outdoor greenhouses protected by radiation-shielding glass, genetically modified crops that can withstand colder temperatures, and even fungal farms growing edible proteins in dark crevices. These innovations will not only feed Martian settlers, but may reshape how we view food itself. In an environment with limited resources, every bite will matter. Every crop will be part of a greater mission, not just to nourish, but to inspire. What we learn about Martian farming will echo across the solar system. The moon, asteroids, and deep space habitats will benefit from the agricultural breakthroughs forged on Mars. By taming a barren world, we set a precedent. Life can flourish anywhere. Yet this journey requires care. We must ensure that farming doesn't damage potential Martian ecosystems. If microbial life still exists beneath the surface, our activities must not contaminate or destroy it. The future of Martian agriculture lies at the intersection of ambition and responsibility. As we look to the future, one thing is clear: growing food on Mars is not just possible, it's inevitable. The seeds have already been planted in our labs, our greenhouses, and our minds. All that remains is to watch them grow under the alien sun.